All right, I just got the go ahead from Crystal. So, welcome everybody. Those of you who've been regular attendees of the Pragmatic Works Tuesday webinars, we'd like to welcome you now to the 3 cloud version of the same. I know we've been in transition here the last few weeks. Thank you for your patience as we work through some logistics around running in Teams as well as we start shifting over to Teams live events. I'm going to kick off, and we'll work through Q&A at the end. But I just want to make sure everybody's ready to roll. So it sounds like everybody can hear me okay. Screen share looks like it's good. So let's get moving here. Today we're talking about the Azure SQL Database Elasticity, and really this is going to be, we're going to be covering queries, jobs, and transactions. So those of you who don't know who I am, let's see if I can get the right buttons clicked here. There we go. My name is Steve Hughes. I am Director of Consulting at 3Cloud. Formerly was a Director at Pragmatic Works Consulting. I've been working with SQL Server, Microsoft BI, Azure, well, obviously not Azure for 20 years, but definitely SQL Server and Microsoft BI. My LinkedIn is there if you want to hit me up on LinkedIn, and my email address for 3Cloud. Really happy to be part of the new 3Cloud team, so looking forward to that. As you can see, I'm going to hype my own book. I am, as you know, for the first time, I've co-authored a few books. This is my first single authoring book on SQL Server 2019. So for analysis services. So feel free to check it out if you're new to analysis services. That book is just right for you. If you've been doing it for a long time, you might get bored along the way, just so you know. But encourage you to check it out. It'll be published in, well, it should be available in November. So looking forward to seeing that come out. A couple things. I do have a note in here. You can find my deck and follow up on my blog. I will have the code, the links to the code and GitHub are both in the deck. And you'll also receive the deck and stuff from Crystal and 3Cloud when we're follow up here. So let's get right into it. Elastic queries. So one thing about analysis, or not analysis service, about Azure SQL Database is there's a few things that we are able to do that when they released it, we're missing, right? So things like cross-database querying and some of the things like that. Well, some of these Elastic functionality that Microsoft's called Elastic allows us to dig into that. So this really covers 3 very distinct topics that all have Elastic names to them, but I want to make sure that you understand that Azure SQL Database can do more than typically we just see in a simple setup and we're ready to go and run a database. So talking about Elastic queries, one of the things that first, people who've been familiar with Polybase, either from working with Microsoft's appliance or Azure SQL Data Warehouse or SQL Server 2019, they jump into this and like, wow, this feels like Polybase. And the reason it feels like Polybase is because we actually use the external table concepts. And what happens is when you create an external table, if you're looking in Management Studio, you'll see there's a folder now for external tables. And those external tables are usually set up with Polybase or Elastic queries. So in this case, Elastic queries are specifically designed for Azure SQL Database and allow you to actually query other Azure SQL databases or Azure Synapse databases from an Azure SQL Database instance. This is really helpful because you now can actually, do the, reference queries in other areas of Azure SQL Database overall. A couple notes right away before we jump into some more details and demos. Everybody wants to know when it comes to cloud, how much will it cost me? Well, in this case, Elastic queries are included in the standard and premium tiers of Azure SQL Database. So you won't have to pay anything extra to actually take advantage of using these. So that's pretty cool. One thing to be aware of, this is one of those, this is a piece of functionality that's been in preview. It's been in preview for quite a while, actually. It's starting to feel like Gmail when it was in preview for a long time, but I'm hoping to see this thing get dropped in GA sooner rather than later. But for the moment, it's still a preview item or preview functionality inside of Azure SQL Database. So make sure that you account for that if it becomes an issue for you for deploying that. So let's talk about strategies. So there's certain specific strategies around using Elastic queries that I want to call out. the two, they're, vertical and horizontal really are the only two ways you can truly partition. We'll talk about virtualization as well, but vertical partitioning is a pretty cool concept if you're looking at building a data warehouse, for instance, in using Azure SQL databases, and there's a limit on the sizes. You're trying to distribute the workload. You can do things like share, create all your tables in one database and share those, and basically query them as external tables inside of your related databases, and be able to share that content. It'd be good for like things like key lookups, date tables, commonly used tables. You could basically create a reference database, allowing you to maintain that reference content in one place rather than 20, and refer to that content across the board. This is the bulk of our demo will be around using vertical partitioning, just so we're all on the same page. Horizontal partitioning or sharding is a concept that's been around a little while in Azure SQL Database, and what it does is it actually allows you to store pieces of the same table in separate databases. So you're actually spreading your database, your table out across multiple databases. This one ends up being a little more complex than vertical partitioning. You have to implement a shard map and go through the process of doing all that, as well as your application should be set up to understand how this is actually happening, so it can actually go out and pull and optimize queries and so on. Currently, there's drivers and stuff for this in .NET and Java, and there may be others as well. But we typically see this involving more of an application setup along the way. It's not something it's because of its complexity, and you have to manage the data and where it goes. It typically is a more complex scenario. But if you have a very large table and you're trying to figure out how to distribute the workload, this is a great option to do as well. The other thing that's going to come into play, and it's kind of a mix of the other two, conceptually, is data virtualization. When data virtualization is a great word that everybody uses, they talk about it, say, oh, we got to virtualize our databases. And everybody looks at it, they try to figure out how to implement, and it's never been easy. Currently, we're seeing a pretty good implementation of data virtualization in Polybase, and we can see some of it here. We've actually used this in some of our solutions to help virtualize data in different places, for instance, like leveraging Synapse, data out there, so you manage a huge volume, but you want to reference some other data, operational data, or something like that. You're able to virtualize all of that into an Azure SQL database using external tables. So it's really, I would say overall right now, vertical partitioning is the easiest to implement, and like I said, we'll show you the concepts there. And horizontal makes sense if you get a database that's too large for what you're doing Azure SQL database, and you're not in a position or you don't want to go to manage instance or Synapse. Makes sense there. And data virtualization just lets you start to realize the benefit of having this data all in Azure SQL databases. Allows you to pull the data from various places and present it to your applications or the users or whoever else needs to interact with the data in a single place. So let's talk about the demo. I created a demo based on Wide World Importers DW. If you look in this diagram, there's a database called Wide World Importers DW-standard. That was actually the location I restored the database to, allowing me to have the full data warehouse restored. When I did the initial implementation, I restored it to an S2, which is a recommended restore process using the backpack files. I have links at the end of the deck that talk about where you can go pick up the demo databases to reproduce this whole thing. From there, I created a bunch of S1 databases. So you have DW1, DW2, DW3. DW2 has the fact purchase table. What I did there is I created the fact purchase table from the original data warehouse, and I moved that data over using Data Factory. A pretty simple copy operation. I use a copy activity, nothing complex. And then I did the same thing for the 3 dimension tables in DW3. So what you see right away is that I now have my fact table and my dimension tables in a typical star schema data warehouse infrastructure in 2 different databases in Azure SQL. And what we're going to do is we're going to actually bring that data into DW1 by using external tables and running queries and creating results where the actual work is being issued back to the underlying or related databases where this data actually exists. So we're distributing some of the workload out, as well as making sure that we could fit whatever size we need to. Now, granted, obviously we can fit this whole database into a single database, but for illustration purposes, this lets us actually leverage external databases. One other note, I have all of mine set up in the same server. So if you're familiar with how Azure SQL Database is done, we can create a SQL Server instance in Azure that can have Azure SQL Databases and Synapse Database SQL pools in it. So in this case, I am actually using the same server. You can use different servers in your reference. As you start to cross resource groups and then you start, you have to manage all the security implications beyond that. One thing I don't believe you can do, primarily because I don't have the subscriptions to test it, is cross subscription. Most of the workloads do not cross subscriptions easily based on our experience to date. All right, so final thoughts before we jump into the demo. Or maybe I'm supposed to jump in the demo now. Hold on. I'm gonna jump in the demo now. Let's switch over to Management Studio. All right, before I get into the demo part, all this code will be loaded on my GitHub, and you'll be able to pull it down from there. Like I said, the link will be in the presentation. So you should be able to go out to my code share and pick up the code for this. What I've done, just so everybody's clear, I actually have created a user. The login has already been created called my Elastic user. So this is some of the things you're going to have to do. So I actually created a user this is for DW2, and I give it data reader permissions because currently in Elastic queries, we only have read operations only. And then I allow it to log in, and I actually created another user for jobs. We'll talk about that in a later demo so that you know that both of them are there. And then basically, this is just a straight table, and I loaded it up. We did the same thing when it comes to users on DW3. You can see here we created, this is probably the most important pieces here. We added users to allow access to the data so we can actually get in and create the external tables. If you don't give that set of permissions, you can't actually connect to the tables. That's how that works. All right, get in the demo. So a couple things to be aware of. We have to use a master key in order to encrypt our credentials. That's commented out. It's commented out, but the code is there for you when you grab the code to go ahead and finish the process out. I've actually added the Elastic job user here in this database as well. And then we're going to go and look at our environment. These are cleanup tasks. So if you want to reproduce it, this is stuff I run at the beginning just to clean up my code, but I wanted you all to have it. I've already run the cleanup. So let's start the rebuild. So the first thing we're going to do is we have to create a scope credential that allows the access in between the databases. And as you can see, good thing I'll be killing this later because you can actually see my password for the purposes of this. We're going to go ahead and create this. All right, simple as that. Now we have a scope credential that allows me to interact between the three databases. So let's start the process of creating external data sources. So external data or Elastic queries operate on a couple of things. We have the external data source that we're going to create. Basically, this is effectively our connection and tells it which credential we're going to use to connect to DW2 and DW3. So if you look here, we actually have these created. Currently today, you really can only use the type of RDBMS. That's what you get. My location is the server name that I'm using to go interact with that, and then the database name and my scope credential that I'm using. The scope credential only worked because I've actually created the same user in both environments. So let's go ahead and create these. What this will do, and I'll show you, is actually create data sources. So if we go here, let me go and refresh this Object Explorer. I'm going to zoom in here in a second. Let me get it expanded first. We are in DW1 and in external resources, external data sources. You can see that I have them. Like I said, let me go ahead and zoom in real quick. So you can see here, we have the external resources already created, DW2 and DW3. These are the ones that I created here. And it lets me know that I now have connections saved inside my environment for the data sources that we want to use. So this is the first step we take in setting up our Elastic queries. We set a connection inside the database that'll be connecting to those. At this point, I've had to do nothing else to DW2 or DW3 except make sure I have a credential that's valid to interact with those data sources. So there's nothing else I have to do in DW2, DW3 in this scenario. All right. Keep going in the code. So now we're going to create the tables we want to connect to. So the first table we're going to create is fact purchase. This is an external table that is created from DS Wide World 2. You'll notice I have commented out the lineage key. I don't actually need the lineage key in my resource. So one of the first things you're going to notice right away is I don't have to include all the fields. I can include what I want to in my external table, and it'll interact with that data as expected. So let's create the table, then we'll run a query against it right after I show you where you can find that. So let's go ahead and run this. And you see here, we're calling out our data source by the data source name we created, which is DW2. Let's execute that. All right, and we go back into tables. Let's refresh this list. And you'll see right away, should be no tables. Those are used for something else. If I go into external tables here, you now see I have DBO fact purchase, and it has in it, as soon as it chooses to expand the field list here. Come on. Let's just see if we can refresh it again. Well, it's not playing nice with me right now on the refresh, but you can see here that we have that fact purchase table we created. So let's just go see what it's got in it. So first of all, let's check to see if we have rows in it, and we'll just run a simple count against it. Hopefully Azure will cooperate and operate. Well, I'm only running these S1. So as you can see here, I got 8,300 rows. And actually, none of those rows are stored in DW1. They're all stored in DW2. And I basically am checking to make sure I can actually query it. So that query was actually executed against DW2 in that case. And I'm pretty sure I probably have some database folks in here. So let's go ahead and include our actual execution plan, run that one more time, because you all will probably want to see this. And go ahead and run that real quick. It's already cached out, so it should be fast. And you can see here, it ran a remote query. I did the compute. So basically, hey, it's going to run the query, select count over there, send the data over to a resulting select statement, but the work was done as a remote query. All right. Moving on. Now we're going to add the dimension tables. So this guy, yep, okay. Out of the way for a moment. All right, so we are going to create dim date, and you can see here that this data source is from DW3. So we're gonna run this as well. And you see it's basically the only difference in the create statement is we have the external table as a reference here. So we have external, and we have the with data source. So when you're creating it, it's actually pretty straightforward. You notice I didn't do any other setup because this is built into the environment. One of the things to note here, we're going to create the stock item, but there are a few data types that aren't supported. So in this case, we actually have a var binary max. That is not supported in external tables, so you can't send that information over. So we're going to comment out that field from the original schema and go ahead and create it without the photo. Which you could make the point that should we really store photos in SQL databases with Azure storage out there, allowing us to do something else. So there you go. Finally, this one here I removed a bunch of columns from just to prove that we can do this. Hit the mute button. Sorry about that, everybody. So the make sure I'm still going good here. Okay. So just so you know, we can see here we're actually commenting a bunch of these fields out. Don't need them. So simplifying the view. Why does this matter? so this matters because we may have a situation where report writers or something like that are using my DW1. They don't need to see all the support infrastructure, and it's kind of like creating a view. But the difference is, it works like a table, and I can create views on this easily in the next tier. But you can actually hide some of this content. Now, one thing to be aware of is, even though I've hidden the views from the external table, we'll find out that it doesn't matter, because we can actually get to it if we go query it directly with the same user, because I as my credentialed user, I have the ability to go look at that data. So let's go ahead and run this. So this is looking at dim supplier for external table, and you can see here it only has the rows that we actually included. And if we try to, I know that there's this field in here. So let's go try to find it, because that's what I'm doing. We're going to get an error. There is no column currently supported in the external table in that way. So let's just want you all to be aware that it won't be available. However, if you, there are ways to bypass it if you have access to the underlying database. Just because I don't give it to you in the external table doesn't mean that it's not available in the external database as well. All right. Complex test. We're going to join everything together. We're going to push all the pieces, and we're going to see what happens. So here we go. At this point, I'm joining all my tables. This would be a typical query I might do for reporting or analysis, and I want to run all this code and just see what happens. We're going to run this, and you can see here it came back rather quickly. Here's our execution plan. Let's get this guy up here. And you can see that the engine is doing everything it can to push much of the content out, but it's still having to join up data inside of the external database. So it's bringing back as much as it can. It's pushing down as many of the filters and join criteria and everything it can to the underlying databases to reduce the amount of data coming back as much as it possibly can. So it is optimized into this. It's built into the platform. The goal is to make this as efficient as possible. Once again, you can see that returns data as expected, and it performs fairly well. Like I said, I'm running on the same server, so I don't have a whole lot of networking bandwidth issues. We know that if you cross servers, you start to hit some limitations that may be in there from a performance standpoint. So just watch your performance if you start crossing servers. Now, the thing is, if you're like, okay, well, I blocked all those people. Well, not really. If someone knows how to run execute remote, and they can hit your connection, so like in this case, DS wide world DW3, I can actually go find all the columns. This is my point. Be careful about thinking that using external tables as a security protocol, you have to set things up a certain way, but realistically, I wouldn't count on it. If you want to secure things, you need to actually secure them. It's obscured, but not totally secure in this case, because using my current credentials, I can go right after the underlying table so I'm actually querying using my data source connection. I'm actually using the execute remote store procedure to run a query against the against the original database, DW3, that has everything about dim supplier in it. But I'm doing this using my data source that I have in DW1. Point is, anybody who knows how to work around this will be able to push and move, push their security to the limit. And you should remember, this is if you're removing fields, doing things like that for external tables, you're doing it for convenience and making it hopefully simpler on most report writers, but not a security mechanism. So I always want to call that out, because we had the same, different tools have the same issue. We think we're hiding something, but we're actually not. All right, let's jump back over the presentation. Okay. All right, final thoughts on Elastic Query. So it's still in preview. And you can only use it with Azure SQL Database and Azure Synapse. We have used it In 3Cloud, we have I've used it for a couple customers now for a couple different reasons. Both work. We have run into performance implications, so be aware of that if you jump into it. Sometimes it doesn't perform as quickly as you'd like, and you may have to use alternative approaches. So I think it's primarily because it's in preview and they're still managing performance improvements across the platform. It is included in the price of the Azure SQL Database. You can work with it in standard. If you want to get better performance, you want to go to premium. And of course that, translates into also if you're using the vCPU pricing model, it works in those as well. And if you cross data centers, remember you will pay egress cost. You cannot, like if I was to go from East US 2 to West US 2, I will pay every time a query is executed from West US 2 as it reaches into an external table stored in East US 2. So if you're planning to use this and you're planning to cross data centers, be aware it will cost you and you're going to need to manage those egress costs. It may not be substantial, but they do exist. Currently, it's only read-only, so you can't do any writes through the external table connections. Don't know if that's going to go away. Right now, if you think about its best use case, it typically makes most sense in a read-only scenario, and will, depending on what you're trying to do. The other thing to be aware of, it's really not optimized for ETL operations. So large bulk operations, where I'm gonna pull a million rows through the external table, probably not a great idea. You're gonna suffer. So be aware that it has some good use cases in reporting, cross database querying, those kind of things, but really pulling it through for ETL, you're gonna suffer the performance that performance implications there, just because you should be doing that natively on the native databases anyways. All right, next one, Elastic Jobs. So if you remember when Azure SQL Database was released, I believe the #1 hot question was, so wait, there's no agent? And there were workarounds and all kinds of things that were done, but Elastic Jobs really is the mechanism to run jobs on Azure SQL databases, similar to what we would have done if we were running with SQL Agent. So a couple things to be aware of. This product is also still in preview, and but it does provide for parallel operations. So if you think about, for instance, if you sharded your database using Elastic queries and you're running a sharded database and you need to run a operation against every shard, this is a great way to do that. It allows you to run it in parallel, tag the databases, create them as a group. Frankly, you can create them, like if you have them all on a server, you can do server operations that run against all the servers. There's some really cool features that are available here. It does require a dedicated job database. So the job executions themselves are free, but the job database is really the expense that you're going to incur. You can run, I think I'm running an S1 for that right now, but you can actually run your jobs on that job database. So that's your cost. And obviously, if you're doing lots of jobs, you probably want to scale that up a little bit just to make sure that it's handling, because that's where all the metadata processing is done, that it's handling it well. So as we look at a job, job is really a collection of job steps, really similar to what you would have done in SQL Agent. So these jobs are SQL statements that can be executed against a specified target or a group of databases in a target or something like that. So what this means is one of the big things you have to keep in mind is that it runs T-SQL scripts. It doesn't actually run a lot of, it doesn't run anything else at the moment. So, however, you can create your jobs in the portal. You can create them with PowerShell. You can create them with the REST APIs or with SQL, and we're going to show you how to do that with SQL. As we dig into the job targets and steps, before I jump in the demo, you'll see in the documentation as you're looking through this that things are pretty much separated into target groups and jobs and steps. So target groups, you can target everything from a single database to all the databases on a server, You can target elastic pools. You can target shard maps. And you can actually set up a target group with a filter. So you could say, hey, I want all the databases in a server except for this database, which is really important. Like in our case, we actually have to do that. And we'll show you that in the demo, because we need to filter out the job database itself, which happens to be on the same server. So when we create the server target group, we want to target everything but the database, the job database itself. When you create a job, it can contain one or more steps, and you get history with it. Your jobs can be executed on demand or on schedule, and it keeps the history for 45 days or longer, which is cool because then you can see the history related to how your jobs are working. All right. I believe, oh, I got one more slide, don't I? Look at that. So on the demo, I always like to tell you how I did the demo. So I actually did an S0 to be my job database. I'm not running a lot of jobs, obviously, for a demo. I created the agent in the portal, and I will bring up the portal here in a second so you can see that as well. And I use it to create some target groups and some jobs. So let's jump into this demo. First of all, in my Azure subscription, sorry folks, let me get this a little bit bigger. All right. I actually have an Elastic job agent that was created. You can see right here is marked as preview. So let's go look at the agent. This is pretty straightforward. You can add an agent to it. There's no additional cost. The big thing is, remember, you have to have a job database. In my case, this is the Elastic Job DB that I created, and set it up and go. So in this case, let's see. So it looks like I had some Elastic jobs, some job executions. You can see those right here. Yeah. So let's see. I'm not sure if I still have everything here. I may have cleaned it up already. Yep, looks like I cleaned up a bunch of this. So, but you can find out about your jobs in the portal, and as well as running, queries against the Elastic, against your job database. So let's go back over to Manage Studio. So this script basically gets you set up for running jobs. Once again, so we have to create a master key. I am going to go ahead and recreate my scope credentials, so everything's set up correctly. All right. I actually, I have cleanup tasks in here allowing you to reproduce each one of these on your own for your demos, just so you're aware. So the SP delete job, SP delete target group, obviously they have to be done in order. So this allows you to go ahead and create that. So when we looked here, you could see that I did not have the target group that we're working on cleaning up because I already cleaned up the first round. So we're going to create a target group, and effectively we have to create the group and then we load it with members. So first thing we do, we're going to create the group, and then we are going to use the next query, the next store procedure, the add target group member, and we're going to add to the target group that we just created, the TGY World DWs, a target of a SQL database, and we are going to give it the server name and the database name. So right now we're going to add DW1 into our target group, and that's it. So let's go ahead and do this. So now I have one member there, and what we want to do is we can actually go look and see what we have in target groups, and you're going to see is I might have a few left over from multiple demos. Okay, so right there. So here you can see that we created the target group DWs right here. This is one we just created, and we can go see who the members are. And all these are currently being run on my Elastic Job DB, so I'm actually running everything in the job database right now from a SQL standpoint. So hopefully there's no questions there. All right, so now we have a target group. We've put members in that group. We're going to add a job. So we're going to do a job that says add a new table or row right now. So here we go. So this job, got it. Once again, we got to create the job or create the container that we're going to put the steps into before we create the steps. And then we're going to create steps. Now, what I've done in the steps here is I'm looking for looking for this table called new table. Really sophisticated name, I know, makes it easy to find though in demos. If it doesn't already exist, let's create that table with one column, which is a unique identifier, and let's insert it in that table as a value. So we're going to create this job step now. All right, so now I have the steps. Let's go back over here. We should be able to go into jobs, and I have add new table or row right now. So you can see I currently have this job. There's not a lot you can do in the portal besides just look at what you have. So that's what we have in this case. We're just basically viewing what's here. Back. We're gonna manually execute this job. I'm not creating any schedules in here because scheduling in the middle of a in the middle of a demo is kind of tough, but you can create schedules as well. So we're gonna run this job. And then we're gonna go look at what we have in job executions right from here. So those of us that are really comfortable in SQL, we can see that we are in the process down here on row 15. It says waiting for child job execution. So it's like, okay, we're running, we're waiting to figure out what we're doing, and it's waiting for job steps to complete. So let's run that again. We should, it should be done by now. So now we can see that we have succeeded and we are good to go. So basically what we're looking for is to run that job, and you can see that we can go look at the log of information that's here. And this is the information that's stored for 45 days. So last time I ran a demo was in September. And it's not always in order. As you can see in here, we actually have this job step that was created and run as well. So, all right. Now that we have seen this, we really need to check and run a query on Wide World 1 just to see what we have. And let's go make this the easiest way possible. You can see here I have this new table. Let's refresh. And let's go ahead and select the rows. Very sophisticated query here, very sophisticated table. I created a new table. I should have put a date on there so we could all see that happen. But now you can see that we actually are filling this table with goods as we go along. All right. Keep in mind that this is two statements, right? So if the table doesn't exist, it's going to create it. And after that, it's going to insert. So it doesn't. So if it did exist already, it's going to keep adding rows. So if you just to make that pretty clear, let's go here. Let's run it one more time. And so that's run. And we should be able to go over here and run this query again. And you can see we have a fourth row in. So it added the new good. All right. So we created the first one just to run against a single database. It ran against DW1. Now we're going to add a new table, and we're actually going to go ahead and delete the ones that we have, so I don't have to worry about it. So make sure that's all good. So we're going to create a new group called target group all databases. We're going to execute this. So now I have this great target group, and I am going to create a new credential name. But this is one thing, this is a caveat you need to be aware of. Because I'm going into server, I actually had to create a different credential that had access to the master database in my server. And the reason for this is it's going to have to go to that server to query the list of databases. So something I forgot to talk about before, but just so you're aware that you need to run that. So we're going to go ahead and run this real quick. Check the quick time check. Looks like I got to pick it up a little bit here. So now I've created that job. We're going to go look at the members for that job, and you can see that it includes members. That doesn't look like it ran the right query. Oh, yes, it did, because it's targeting the server. So we actually have the server is listed as the target. We're going to create the job, which is add the good table. As you can see over here, I actually have a good table in DB1 as well. I'm gonna go ahead and say, all right, hey, if this table doesn't exist, go ahead and do it. Here's my credential name that I'm gonna use, and we're gonna go against all of them. So we execute this, and now I have my new job. So once again, Same basic syntax, different table. All right, let's run the job. And that, and then we're going to check our job execution, see how fast I can do this. We should see a bunch of in progress right here. So we have 5 potential databases that it's running against, I believe. We should start to see problems. So here we can see that there is no Elastic job user for 2 of the databases. And this is true because we selected the entire list of databases we had. The Elastic job user only exists in the DW1, DW2, DW3. So you're going to get a reasonable amount of information. You got your target IDs, and there's your database names that are in question. So we can see here, these 2 databases do not have Elastic job user in it, which is a problem. So we're going to here, we're going to look for active jobs because it runs a certain number of times. And you can see, let's see if it's got it in here. Yeah, so it runs multiple attempts. So we're going to have to cancel our jobs. We're going to pull the job ID off of here real quick. Replace this because I want to do is reset. And it has a restart number that you can set in the jobs. I left it at the default, which I think is 10. I'm gonna go ahead and stop the jobs. Let's try again. That's weird. I didn't get that error last time. Huh. Not sure why we're having that problem. Let me just see if we still have active jobs. Did I grab the wrong thing? I grabbed the wrong thing. I need to grab the execution ID. Demo time. There we go. And see, this is one of those pieces I have to do live. Let's try that again. There we go. Pulling out the execution. We should have no active jobs. Ta-da. All right. So now we're going to exclude some members. So I'm going to take the same target and I am going to add a membership type of exclude. And I'm going to exclude the 2 servers I don't want to have. So you can see here I have membership type exclude, what we're going to do, and the add target group member works to update these for you. So let's go ahead and do this. And what this is going to do, it's going to remove those 2 databases. And then we're going to run the job one more time. And we're going to go see, first of all, we should see that we have fewer databases being executed. Oh, there's nothing left there because they all successfully worked. So we can actually look at the executions. Let's see here. You have that query up here. If we want to look for the executions where it looks like this. And you can see that we had some cancels in there, but now we have successes with the jobs we just ran. So let's see if that's, so now you can see that there's a lot you can do with the jobs. The big thing to keep in mind is that it does require SQL syntax to do the job. So let's go check out the deck here. And let's get running again. So I think we cover everything in there, but keep it, like I said, one of the limitations is you have to use T-SQL. So let's talk about transactions. So in the few minutes we have left, Elastic transactions are actually support for MSDTC or Distributed Transaction Coordinator that you can do. What's interesting here, what's really cool about it is you don't have to do anything to use this, right? As far as install or turn something on, it is now built into Azure SQL Database. So it allows you to do cross-database transactions across Azure SQL Database. I don't have a demo for this because I didn't take the time to write an application to show this work. But there's a .NET library already set up that supports this in the current version. You can span databases and servers. You can use PowerShell to help with that. And you know, the one thing they talk about is transactions need to be fewer than 100 databases. There's no technical limit, but you'll suffer performance if you do. Like I said, I don't have a demo of this one just because the only way to really effectively demo this is to build an application. And I work in databases and I don't build applications very often. So there you go. But if this is something you've been looking for, I know that's one of those things that people have requested from Microsoft is how do I get MSDTC working? it is working. Elastic transactions are in place and can be used to support distributed transactions across Azure SQL databases now. Currently, the limitations on this, you only can do Azure SQL databases. It does support .NET, but it does not support T-SQL. So if you have done this before with begin distributed transaction syntax in T-SQL, that is currently not supported, and neither is WCF. So if you're working with WCF, those transactions using WCF are also not supported at the moment in Elastic transactions. This page basically tells you the links for the demos. The code, I have all the T-SQL code. I do not have the Azure Data Factory jobs, primarily because I was using copy activities. So super easy to do. My blog basically tells you, it gives you a link to that as well if you're looking for that. So, and I think we did it. Questions, and I think Crystal's gonna help me with questions. Hopefully you've had questions in your spot, so I'll let her open her mic up and fire questions at me. Unless there's no questions.
We have a few questions here. Let me just scan through really quickly, because actually, let me just give a few seconds for people to submit their questions, because I know there's a little bit of a delay. So let's just give a few seconds here. All right, let's see. There's a question that says, linked servers were a no-no in the past. This seems like linked servers like it should be avoided. What are acceptable use cases in your opinion?
So I would consider this a much better solution than linked servers. And the reason is because of how it doesn't require all the interactions, and performance is retained pretty well. So you can use it for reporting scenarios, for shared key databases, those kind of things, so you manage this data in one place, that kind of scenario, pretty effectively. We've also used it in order to interact with Synapse, so we could bring data from Synapse to SQL, because some drivers and some tools don't actually work with Synapse yet. So it gave us that option as well. Overall, I'd say about the biggest limitation is as you start to build it up, keep in mind if you do really large transactions, you will suffer the penalty, especially if you cross data centers or something like that. But overall, while they operate similar to link servers, this is a much better solution in the long run.
All right, the next question is, how would you compare Elastic Query Job to Azure SQL Managed Instance?
Azure SQL Managed Instance has full SQL agent. So if you are running full jobs, then you need to run more than just T-SQL operations. Then using SQL agent and managed instance makes sense. However, if you are running basic T-SQL like we talked about in Elastic Jobs, you can actually leverage that at a much lower cost point or lower price point than spinning up an Azure SQL managed instance, Azure managed instance, they call it now. So my opinion on this is that Elastic Jobs should be your first choice, unless you have a special case that can, that's outside of the capabilities of Elastic Jobs, because the cost and efficiency is better.
All right, give it a few more seconds here since there is a little bit of a delay. For any last minute questions? All right, well, if there's no other questions, because I don't see any more. So if there's no other questions, I want to thank everybody for attending the webinar. I know this is a new process, so I want to thank you guys for attending and making the process pretty smooth. If you guys have any questions, if you guys want to give feedback about the process, please feel free to reach out to myself. I'll be more than happy. If you guys have any questions about the webinar, please feel free to reach out to me, or Steve will be more than happy to take care of you guys. I hope you guys have a good rest of your Tuesday. As always, Steve, thank you so much for hosting. We appreciate it. Yeah, and you guys will receive the email tomorrow in your email box. And this should be up by noon. The video should be up on our YouTube channel by noon tomorrow, Eastern Standard Time, but you guys should receive an email link in your email box tomorrow around the same time, around 12 p.m. Eastern Standard Time. Okay, well, I hope everybody has a good rest of your Tuesday. Enjoy your day. Again, Steve, thanks so much for hosting. We appreciate it.
Thank you. You all have a great day.